Welcome. This is the Ag Engineering Podcast, where we talk tools, tips, and techniques to improve the sustainability of your farm. I am your host, Andy Chamberlain from the University of Vermont Extension, and this podcast is supported by Northeast SARE, providing grants and education to advance innovation in sustainable agriculture. We're trying to improve the industry by chatting with farmers and getting their input on tools, tips, or techniques that have changed the way they farm for good. Many of these practices affect multiple areas of the farm. Whether it be environmentally, emotionally, physically, or financially, we share the knowledge to promote sustainable agriculture, lifestyle, and business. Thanks for having a listen. Now, let's get started. Today's episode comes to you from Bennington, Vermont, where we chat with Chris Callahan of UVM Extension. He's been with Extension over 8 years, working with vegetable farms on many different kinds of projects. Chris, welcome to the show.
Thanks, Andy. Nice to join you.
So if you could describe what you do in one sentence, what would you say?
Only one sentence. Okay. What I do is try to help the people who make food and grow food do it better using technology when it makes sense, in a nutshell.
So for those of you that don't know, Chris is my boss, so we work quite closely together, and I thought it was time to bring him onto the show as part of the ag engineering team of UVM Extension. So today we specifically wanted to talk about precooling. So Chris, what is precooling?
When we're talking about pre-cooling, we're talking about a post-harvest practice. So we've got produce that's been harvested, and we want to bring it down to storage temperature as quickly as possible. And so pre-cooling is a series of, or a collection of tools and systems we can use to rapidly reduce the temperature of what we've worked so hard to produce.
So I know there's a few different ways to do pre-cooling. What's a couple different ways that a farm could implement this practice?
Yeah, let's go from simplest, most common to most advanced, least common. And one very simple thing that can be done is just storing harvested produce in the shade. And so this is most commonly done right out at the field prior to moving it into a wash pack shed or a cooler. And so just having some shade is actually a really simple, zero energy way of helping to bring field temperature down. The next most common practice is probably just what we call room cooling. So you have a CoolBot room or a cooler, a walk-in cooler, and that, just placing product in that cooler, packed in harvest crates or containers, and just allowing the product to come down to temperature naturally by sitting in the room. Getting a little bit more advanced might be something like forced air cooling. And I think we're going to probably talk more about that in a minute. But the idea is bringing that cool air in a cooler across the product inside containers to bring the temperature down even more quickly. Hydrocooling is another approach where you use cool water or cold water to with product immersed in it to bring the temperature down. And then there's even more fancy stuff, like obviously you can ice product if you have an ice maker, right? And you can use vacuum cooling as well, sort of more advanced techniques.
There's quite a few different ways to cool your crops now that you bring it up and we think about it.
Yeah.
So what issues or pain point would forced air cooling or any of these cooling practices really help to eliminate?
Yeah, so I think it's important to just ground ourselves by remembering that produce is alive. And what we're working on here is trying to reduce the rate of respiration. So the fact that produce is alive means it's going to continue to consume sugars and convert those sugars, even in storage, even after harvest. And so the way we control that is by controlling temperature and by reducing temperature in particular. So we're really trying to slow that respiration way down. And so what are the pain points? Well, it's really just about any quality loss in storage, short of freezing or chilling injury. but maybe you're seeing wilt in greens, and maybe you're seeing shriveling in some larger fruit, drying out, for example. These are all things that can happen as a result of just excessive production of heat by the crop. Um, and oftentimes we're when we first see that, we think, oh man, cooler's too dry. And that may be, but it would have to be a very extreme case of low humidity to cause that. Generally, what you're seeing is the result of just bulk heat being produced by the crop itself. And so pre-cooling is really all about bringing that temperature down all throughout the crop and in what it's packaged in. So that's number one. And of course, what that leads to is happier customers, greater storage life, greater storage quality. Um, so getting that temperature down is really an important first step in securing the cold chain, and the cold chain leads to product quality.
So aside from harvesting it early in the morning or in the night while the product's still cool, what are what's some of the equipment that is used for all these different practices of hydro cooling, forced air cooling, and whatnot?
Yeah, so for hydro cooling, it could be as simple as a dunk tank filled with well water. And we want to be a little bit careful with hydro cooling because of the risk of infiltration. So especially in hollow core fruits, if you dunk them in water that's quite a bit cooler than the fruit or is, then it can lead to infiltration. We want to be careful about that. Typically, the rule of thumb is keep the water no more than 10 degrees cooler than the fruit. So it could be as simple as a dunk tank with just well water, right? If you consider what field heat generally is or what the temperature of the produce generally is, well water is pretty good. It could be fancier than that. Could include a chiller, something that actually makes the water much cooler than well water. I've seen growers use dairy bulk tanks and just chill at 200-300 gallons or more of water, and then use that as a final dunk on, for example, a greens washing line. So get the greens right down to 34 degrees before going in the cooler. And they've seen great storage life benefit. So that's for hydrocooling. There are large hydrocoolers or custom, specific systems specifically built for hydrocooling. Don't see many of those on the farms we work with. Forced air cooling. Well, the work that you and I did, Andy, in terms of pulling together some simple plans for forced air cooling plenums with fans that just um, allow a step above room cooling in a walk-in cooler or even in a cool-bodied room where we're pulling air directly over the crates or harvest cartons. And it gets more complicated from there. Vacuum coolers are very specific systems um, that usually come at a pretty significant cost and require a fair bit of maintenance and specific operational training. Um, Icing, of course, is something that a number of growers do, especially for things like broccoli that have a fair bit of mass, but also benefit from low temperatures throughout distribution and storage. So,
On one hand, you mentioned earlier about keeping the water temperature only 10 degrees less than the crop due to infiltration. But then in your next sentence, you said you can use well water, which can be way colder than ambient uh, or chilled water. So, do you need to worry about infiltration on all crops or really just like the tomatoes and melons?
yeah, I used to think it was. I mean, my understanding used to be that it was really just the hollow core crops, things with seed cavities, if you will. But I've seen some more recent work that actually points to infiltration, even in greens. And I think it's less infiltration, more it's capillary draw. So the veins of the leaves are actually pulling the water in and rehydrating. So kind of regardless of what we call it, it looks like it's actually a fairly common thing in in almost all crops where you take a crop, you put it in water, it's going to absorb that water one way or another. Um, So it's important to be careful about that. But
I guess you kind of want that at some point, at some aspect to kind of hydrate the leaf and keep it crispy, right? So it's kind of catch 22, I guess.
yeah, and again, whenever we're using water that's coming into contact with produce, we want to make sure that that's safe and sanitary water, right? So the issue with infiltration, of course, is that it might draw in stuff that's on the surface of the crop, which could be a problem.
I guess it makes sense to keep that dunk tank water pretty fresh and clean then.
Yeah, and the other thing, Andy, is stepping. Think if you have multiple tanks in your line or multiple places where water is used. Think about maintaining temperatures of those different sources of water in sort of a staged step down, right? So you got field temperature on the one hand coming in, and maybe the first rinse is slightly warmer than what the final or subsequent rinses might be, right? So you can step your way down to it.
Yeah, and of course they'll probably kind of get that way based on but two things, the way they fill the tanks, because it's going to take fill the hoses and the pump first before that real 40, 50-degree water gets to the tank. So your second tank might be colder. And two, the first tank is going to warm up the most because that's taking out the most field
Yeah,
heat. So
right.
I guess that might kind of happen naturally.
Yeah.
So for these different ways of cooling, is the equipment particularly expensive?
It certainly can be. I think like most things, there's a range of possibilities and a range of options. Was one of the reasons why I was so interested in working on some of these simple forced air cooler systems, is just seeing what we could do for relatively um, relatively low budgets. We're talking about some common building materials and lumber and plywood, with the most significant cost being the fans, the blowers that we use for doing the forced air cooling. Um, so I'm trying to remember. I think that's essentially under $200 for those. Again, with most of the cost being in the blower. Yeah, $198, and so those plans are online, and you're bringing your own labor to it, but it's not significant labor. Um, so something like a pop-up tent at the edge of the field is for providing initial shade during harvest is pretty low cost option as well. Certainly can spend a fair bit of money on this. I've seen vacuum coolers, for example, that are size of a tractor trailer or larger, and all sorts of refrigerant uh, systems running, and those are not small dollar items. But I think what we've come up with is actually fairly accessible for farms that we work with. And again, hydrocooling can be fairly straightforward, and really sort of the important thing is paying attention to the details of the temperature of that water. But it can be as simple as a tank and well water, like we said.
Yeah, and even the cost of a tank is going to be close to $100. So between $100 and $200, I guess, is what it takes to really get started with this, whether it be hydro cooling or forced air
Yep.
or shade. A pop up tent's a couple $100 too.
Right. Right.
So there is some cost to this. Some cost could be quite steep if you get into vacuum cooling or a large scale hydro cooling conveyor type system. But what are the financial savings of pre cooling? You mentioned shelf life, obviously, so that's going to increase.
Right. And it's sometimes difficult to put a number on what you gain economically from having higher quality produce, for example, or higher quality produce for a longer marketing period, because sometimes it comes down to a sales opportunity or a market opportunity that's a bit variable. But the what this buys is a little bit of peace of mind, a little bit of convenience as well. So your harvest window can be a little bit more flexible because you now have a way of bringing temperature down predictably. So maybe there's some scheduling benefit or some labor benefit. You can get more people on a specific harvesting task sooner, for example, and knowing that you have the capacity to deal with it in the cooler. Um, so yeah, we haven't done real hard economic savings estimates on this, but it really does come down to just flexibility in harvesting and flexibility in marketing. You're going to be able to have a longer marketing period for the product. There may also be, you might be able to reach newer, different markets or more discerning markets as well, who are willing to pay a higher price. I haven't seen it as much of that as I would have expected, but I think there's a possibility there.
Yeah, unfortunately, I think it's kind of expected that you have crops for as long and consistently as possible. So I guess it can just kind of help keep up that standard.
Yeah.
If there was one pre-cooling tool that you would choose to implement on the small scale farm that we work with, what would you recommend investing in?
That's a great question. The one thing that I've had most farms come back to me with and say, "Man, am I glad I did that," is as simple as a thermometer, an instant read piercing probe thermometer that can actually measure pulp temperature. So understanding and the reason why, well, on the one hand there's that, on the other hand there's also USB temperature loggers or remote wireless temperature monitoring. The thing those two tools bring to you is visibility into things that you weren't seeing before. And so in the first case, if you're not monitoring pulp temperature, you don't really know what temperature your product's at. If you're depending on the cooler thermostat to tell you what temperature things are at, that's a long way from the melon at the center of the pallet, right? So being able to know what temperature you actually have in the product is really enlightening and has changed practice for a number of growers I've worked with. The USB data loggers, temperature loggers in particular, and or wireless temperature monitors are the cool thing about those is you can watch it and log it in real time, and so you can actually see, you can do side by side tests. What if my greens are in this container in the walk-in cooler versus that container in the walk-in cooler, how they cool at different rates. And that has, in particular, that has really influenced the practices at one large greens producer we work with, where they've changed their harvest containers as a result, because the containers they had were fairly they held a lot of greens, which was good on the one hand, but that's also a lot of mass that has to cool down. They were invented, and so made it difficult for the real for the cool air to get in. Ultimately, they also really started to depend a little bit more on their dunk tank to cool the greens rather than the walk-in cooler. So it actually changed the flow on the farm.
That's one thing that I learned a lot on the forced air cooling project that you mentioned earlier that we worked on, and I'll have another episode just on that coming up later. But we used these temperature loggers to track it real time, track the pulp temperature, and it was really cool to see uh, how warm a melon actually stays. You think you throw it in the cooler, so therefore it's cool and it's good, but turns out it actually takes like 24 hours for a melon to actually reach the cooler temperature. But if you implement forced air cooling, you can do it in half the time. So that was something that was just like really interesting.
Yeah, it's sometimes helpful. Sometimes it's not really intuitive to think about heat transfer, which is what I spend a lot of my time thinking about. And so sometimes it might be helpful just to think about yourself, your body, and if you are wrapped in blankets on a summer day, right? We know what's going to happen. And you take the blankets off and you stand in still air, and you're probably still warm, but not as warm as you were, right? And so that's the idea of maybe you take the melons and you spread them out a little bit, and they're still in a pallet in a cooler. But then if you stand in front of a fan, now we're talking, right? Now you can feel yourself getting cool. And so that's really what we're talking about when we do intentional pre-cooling, and in particular forced air cooling, is we're taking the air, the cool air, and blowing it over the product to bring the temperature down more quickly. And I should say some people get nervous about drying product out when you do that. And the key to remember there is unless you really have a very dry cooler, which again I believe is fairly uncommon, the air in the cooler is actually quite humid, and so there just isn't a whole lot of capacity to pick up moisture. So it shouldn't be drying anything out. And so I just want to encourage people to not be afraid of forced air cooling in their cooler because of concerns over drying. It shouldn't be happening.
That was a great little comparison there with your person and thinking about just like how you cool or how a crop cools. I mean, it's not complicated when you think about it, but you typically don't stop and think about how something's cooling. You just want to get the crop in the cooler and move on to your next thing. So makes a lot of sense. That was a good way to put it. Is there anything else that you wanted to share that we didn't bring up yet?
So a lot of our work in this area was funded by a SARE research and education project, and that's USDA Northeast SARE, Sustainable Agricultural Research and Education. So just want to acknowledge that support and thank SARE for their continued support of this kind of work focused on bringing sustainable practices to agriculture in the Northeast. And just wanted to note that a lot of what we've talked about is on our website, on the AgEng blog at go.uvm.edu/ageng. And I know Andy will include specific links in the show notes and probably highlight a few.
That's right. So if you want to contact us at all, visit our blog, as Chris just mentioned, and that's where you can find out more information on pre-cooling, hydro-cooling, forced air cooling. We've got quite a few articles on all those subjects. So thanks, Chris, for coming on the show and giving an overview of pre-cooling.
Andy, thanks for being an awesome guy and for being a great part of the work we do. And thanks for getting this podcast going. I think it's been really great to see it develop and grow, and really appreciate the work you do. Thank you.
Thanks for listening to today's episode. If you learned something today or plan to make a change on your farm, let me know. I'd love to receive any feedback you have. Just click the link in the description to submit the form. It will help the future of this podcast to be a resource that is helpful for you. And while you're at it, I hope you go ahead and subscribe, share this with a friend, or leave a comment. And if you want more information, check out the show notes on our website at agengpodcast.com. That's agengpodcast.com. Thanks for listening, and I hope you have a great day.
The proceeding has been a production of University of Vermont Extension. For more information on Extension, log on to www.uvm.edu/extension.